So in last lecture we see that for liquid droplet delta P that is equal to 4 sigma by D. So this is the another method to calculate the delta P for liquid droplet. So consider this is the liquid droplet, and here the inside pressure inside the droplet, that is P1, and outside pressure, that is P2. So what is the pressure difference? Delta P, that is equal to P1 minus P2. Okay, so now if you see the large view here, so the distance, that is dl2, and here the distance, that is dl1, and surface tension is acting on the surface. Okay, and the radius here, that is r1, and here the radius r2. So for delta P, this is the standard formula, that is delta P, that is equal to sigma by r1 plus sigma by r2. Okay, so delta P, that is equal to sigma by r1, that is the radius of the sphere. So r1 is the radius of the sphere. Okay, so r plus sigma by r2, that is equal to r, that is the radius of the sphere, that is r. So that is equal to 4 sigma by d. D is the diameter. So d equal to 2 into r. So from here you can calculate that delta P, that is equal to 4 sigma by d. So this is very, very important formula. Same as the same formula like this. So for soap bubble we calculate that delta P, that is equal to 8 sigma by d, but just difference is there, that is delta P, that is P1 minus P2. So delta P, that is equal to 2 sigma r1 plus 2 sigma r2. Okay, and 2 sigma because of 2 layer, to do 2 layer. So 2 sigma by r plus 2 sigma by r, that is 4 sigma by r. So delta P, that is equal to 8 sigma by d. And for liquid jet, so this is for liquid jet. So the outside pressure, that is P2, and the inside pressure, that is P1, surface tension is acting on the surface, and delta P, that is equal to P1 minus P2. So delta P, that is equal to sigma by r plus sigma by infinity. So sigma by the radial distance from center line to the outside, this is r, but here the vertical direction, the radius is infinity. So sigma by infinity. So delta P, that is equal to sigma by r equal to d by 2, we know that. So that is equal to 2 sigma by d. So delta P, that is equal to 2 sigma by d. So P1 is the inner pressure and P2 is the outer pressure. R infinity because straight line of the upper portion. So that's why R is equal to infinity. Okay. Now let's try to solve one question that is very, very important. Try to solve that question. So try to understand that question first. A glass tube of 2.5 mm internal diameter is immersed in oil of mass density 940 kg per meter cube to a depth of 9 mm. If a pressure of 148 Newton per meter square is needed to form a bubble which is just released, what is the surface tension of the oil? You have to calculate the surface tension of the oil. Okay, so a glass tube of 2.5 mm internal diameter. So here this is the glass tube here. So the internal diameter of this glass tube, that is 2.5 mm, is immersed on a oil of mass density. So outside there is a oil of density, that is density is given 940 kg per meter cube, to a depth of 9 meters. So here this age is given, that is 9 mm. If a pressure of 140 Newton per meter square is needed to form a bubble which is just released, what is the surface tension of the oil? So P dash, so P dash, if you want to calculate the P dash, that is equal to rho into G into H. So P dash is the pressure just so in that location. So rho into G into H. So 940 into G 9.81 into H. What is the value of H? That is 9 mm. So that is equal to 0.009 meter. So this is 83 Newton per meter square. So if you want to calculate delta P, so pressure is given 148. If a pressure of 140 Newton per meter square is needed to form a bubble, so delta P, that is 148 minus 83, that is Newton per meter square. So 65 Newton per meter square. So this here the droplet formula will be applied. So for droplet formula, delta P, that is equal to 4 sigma by d, because the outside the droplet there is a fluid. So that's why we use the delta P 4 sigma by d formula. So sigma, that is equal to 4 delta P into d by 4. So delta P, that is 65 into sigma, that is given in the question, sigma delta P into d is the given in the question. So 2.5 mm, that is 2.5 into 10 to the minus 3 divided by 4. So this is equal to 0.041 Newton per meter. Okay. So now remember this data here. There is a liquid and there is a air, and there is a bubble are there. So the curvature here, in that curvature there is a P1 must be greater than P2. So and the depth is h. So if you want to calculate delta P, for that case, this is 4 sigma by d, not the, so here the delta P formula, not the 8 sigma by d. Okay, so here we apply this formula delta P, that is 4 sigma by d, not we use the soap bubble formula. Okay, because there is a inside air, there is a outside air. For that case we use the soap bubble formula, that is 8 sigma by d. But in that case we use the water droplet formula, that is delta V, that is 4 sigma by d. So P1 minus P2, that is equal to 4 sigma by d. So P2, that is equal to P ATM plus rho gh. So P2, that is equal to P ATM plus rho gh. So P1 is the pressure inside the bubble and P2 is the pressure outside the bubble. So P1 is the inside pressure and P2 is the outside bubble pressure. So here large curvature defined, less pressure difference. Okay, if there is a large curvature, then there is a less pressure difference. Now try to understand one important question, that is probably it is a GATE previous year question. So try to understand that question, very important question. So the difference in pressure, that is the unit is given is in Newton per meter square across an air bubble of diameter 0.001 meter immersed in water. So here air bubble is immersed in the water. So we use the water droplet formula. Okay, delta P, that is 4 sigma by d. Okay, surface tension is given, that is 0.072 Newton per meter. So since the air bubble is immersed in water, there will be only one interface. So the formula for liquid droplet is applicable. So why this is applicable? Because since the air bubble is immersed in water, there will be only one interface. So formula for liquid droplet is applicable. So delta P, that is 4 sigma by d. Sigma is given, that is 0.072 divided by diameter, that is given, that is 0.001 meter. So this is the case. So that is equal to 288 Newton per meter square. So this is very important question, and very important question, remember this. And why this formula is applied, so this is also very important. And this type of question are asked in GATE, ESC, SSJE exam and other competitive exam. Very easy question, 4 sigma by d, 2 sigma by d, 8 sigma by d. So this is my handwritten notes. You can download it from the description. The PDF link is available on the description. Thank you.